Hey guys, it is day 3 of our NTI madness, and we are looking at area and circumference of circles. I know it's been since I think Unit 3 was when we did area of circles and circumference of circles and all that jazz. And what I wanted to do was I wanted to just kind of give you a quick reminder of how we handled those problems because it's been a minute. And the way that, if you recall, we had some general vocabulary that helped us with circles. But thanks to my wonderful fourth period, they came up with a nice little way to remember the relationship order that we talked about the most, which was calling Dr. Rico right away. And this table that I just set up for a circle has everything that's about a circle inside of it. It's got your circumference here with C, your diameter. Okay, let's talk about that. Circumference is the distance around, diameter is the distance across going through the center, and then the radius is the halfway distance from center to edge. And then the radius squared is if you took the radius and you made it into a square. And then, of course, the area is all of the space that's inside. So we have all of these relationships, and we found that there was some common constants that were between them. The first one being right here with diameter and radius. If you take the diameter and you cut it in half, then you'll have the radius, and that makes sense because it's only halfway across. If you take the diameter and you multiply it by the magical number of pi, which we just celebrated Pi Day this past Saturday, 3.14. If you multiply it by 3.14, then you'll know how far it is around the circle, the circumference. And if you take r and you multiply it by itself, so if you take r and you multiply by r, you'll get r squared. It's like you're squaring a box. And so that one's pretty obvious there, r to r squared. And then lastly, r squared multiplied by, once again, our number pi will get you to, it takes 3 of these squares, roughly, about 3.14 of them exactly, to find out how much space is inside the circle. And so that was the relationships that we talked about with circles. So if this little table will help you answer some of the questions throughout the lesson today, then use it. Please, by all means, use it. There are some questions in the list that ask about the formulas, and there's essentially formulas derived from these relationships. And so, if you know the relationships, you should be able to figure out the formula. So let's dive right in. Number one, I kind of already talked about a lot of these answers. A line that goes from one end of the circle to the other and crosses the center point. That would be this one right here, which we call diameter. So the first one that you're going to run into there is diameter. What's the formula for the area of a circle? If we want to know the area, we have to take the radius squared and multiply it by pi. You can see that from our relationship. So which one shows that? That would be A here, pi r squared. This one over here, 2 times pi times radius, is how you find circumference. 2 radiuses would be diameter, and then times pi would get you over circumference. So like I said, all of these are kind of related to these relationships. So if you understand this, then you're going to be in really good shape. You might want to draw that or write that out if you're having trouble, just to kind of help you get around. What's the formula for circumference? Well, there's a couple that would work, but it's definitely not pi r squared. We just talked about that, so it's got to be the other one, 2 radiuses multiplied by pi, and that would be b. So you should be able to run through this pretty good if you have a recall of what this is. All right, let's go down to number 4 here. So now they're going to start giving you information about the circle and then asking you about things. So what is the radius of this circle? Well, if you look at the circle, the red line that they're giving you is the diameter. So you could come up here and think, okay, well, if my diameter is 18, and they want to find out what the radius is, that would be dividing by 2 to find out that the radius is 9. So that's number 4. Okay, I'll kind of do these on this table for all of the problems. So 9 is the radius, and that's what you would select on the fourth one, which would be in inches because this is in inches too. So C. So there's your first 4. Let's open up the next one. I know I'm messing around with different ways to go through this. I think this might be my favorite now because I can do more than one question on one page. But we'll see how it goes. All right, so this particular set right here starts with number 5, and they're giving you the radius. So for this particular page, oh, my battery's getting low on this, so I'll probably have to connect. Hopefully, it will not die in the middle of the video. We'll see. Okay, so I'm going to make my table. Call Dr. Rico right away. So diameter, radius squared, and area. Okay, so this particular one, number 5, I'll do this one in red. Number 5 gives you, looks like they're showing you a radius here because it's only going halfway across. So we will put 3.5 there. And it asks you to find the diameter. So that relationship, if it's divide by 2 coming this way, then coming back, remember you just do the opposite. You multiply by 2. So we double that and we get 7. So this would be 7 millimeters, and that's what you'd pick for number 5. Pretty easy stuff there. Let's go on to number 6. Number 6 wants to know the circumference, and it looks like they're giving you the distance all the way across, which we know to be the diameter. So you got 12 centimeters here for diameter. And remember, the relationship between diameter is that it would take 3.14 of these blue lines that I'm highlighting here to go all the way around. So like that would be like one of them from there to there. And that would be another one from there to there. And it would take a third one to get like right to there. And then the little bit extra is 0.14. So it takes 3.14 of 12s to go around that. So what you have to do, and I'm assuming based upon the decimal looking answers, is that you need to take 12 and multiply it by pi's approximate, which is 3.14. As I said, this past March 14th on Saturday was the day that mathematicians celebrate Pi Day, and that's why, because of 3.14. So that's 37 and 6800ths. So 37 6800ths would be B. So that's the one you should select on number 6. So that one was 37 and 6800ths. This was number 6. All right, let's do a different one. Let's do number 7 here. This one is asking for the area of the circle, and they're clearly giving you the radius, and it's 3. So let's jump up here to our table. If the radius is 3, so we'll put it here. This is number 7. Then that means that we need to go to the right on our table. And to go to the right on the table, we got to go to the square. So we got to multiply r times itself, and 3 times itself, 3 times 3 gives us 9. So the square is 9. So if we squared this and we did 3 centimeters times 3 centimeters, then we would have a box that looks like this. And that would be 1, 2, 3, 4, 5, 6, 7, 8, 9 square centimeters. All right. So the radius being squared, made into a square, is 9 square centimeters. So this would be centimeters squared. And we already talked about that the relationship between these two is, once again, pi. So we have to take 9 and we have to multiply by pi. And it looks like all the answers are in decimal form. So we will need to do the calculator for that one, times 3.14. And that should give us our answer for the area, 28.26. So 28.26 centimeters squared. And what that's showing is that it would take about 28.26 of these little boxes to fill in this entire square because it's area. We're finding the area. So that's number 7. You have 28.26. We only have a few more left. So let's open up the last couple of pages and let's do this. Excuse me. Okay. So problem number 8, it looks like it's giving you a diameter and it's asking you to find the area. So for these last problems, because it looks like all the last are on this page, we're only going to have one more called Dr. Rico table. So here we go. Call Dr. Rico right away. We got our relationships. We know how they relate to each other. We know circumference is the distance around, all the different things. This time they're giving you the diameter, which I will do in purple for number 8 here. So number 8, we're given 12 inches in diameter, and they want us to go all the way over here to area. Okay, so the first thing that we have to do is we've got to find out what the radius is, because there's not a relationship clearly between diameter and area. We got to get to radius first. So the first thing that we have to do is we have to cut it in two to find out that, the radius is 9. And so if the radius is 9, now this could get confused with the last problem, because remember, the squared radius was 9 last time, but this time just the radius is 9. So if we square a 9-inch by 9-inch radius, then that means that the radius squared would be 81 square inches, because 9 times 9 is 81. So be careful with that. I could see some of you doing 9 times pi to get area there, but that would be wrong. So we multiply times r to get over here. That gives us the area squared. And then, of course, we have to multiply by pi to get over to the area. So we got to multiply 81 times 3.14. That's why you see these really big answers for your options for this one. So 81 times pi, and that will give us the area of this shape, 254 and 34 hundredths. So 254 and 34 hundredths inches squared, and that would be B for number 8. So picking B for number 8. Only got a couple more left. We're going to wrap this thing up here in just a bit. So now we're doing circumference. Circumference, that means we're moving to the left on the table. And they're giving us the distance from center to edge, which we know to be radius. So we're going to go throw 14 in for the radius. 14 inches for the radius. This is number 9. And we're working to the left. And coming back to the left, we know that we have to double the radius to get back to diameter. So that's going to give us 28, because 14 doubled is 28. But remember, they don't want diameter, they want circumference. So we got one more step to do, and that's to get to circumference from diameter, which, of course, is by using our favorite number, pi. So 28 times pi will get us there. So let's do that math. 28 times 3.14, 87 and 92 hundredths. So 87 and 92 hundredths. These would be inches, not squared because it's a distance around. So this one says to the nearest whole number. So you might say, well, I don't see it, 87. It's rounding, so that would be about 88 inches is what we're dealing with here around this figure. So 88 inches. All right, and then the last one, we're going to wrap it up right here with number 10. Okay, number 10, let's go read this one about Daniel. What a great name. Daniel wants to buy cookies for his friend, and the radius of a cookie is 5 inches. Let's sketch that. It's a big cookie. Must be like a cookie cake. 5 inches. Okay, like go get a tape measure and like a 10-inch cookie. This is a big cookie. All right, so we're talking about large distance around here. So we know that the radius is 5, and they want us to find the circumference. So once again, we're going to the left on the table. So 5 is R. radius, double to get to diameter, and then times pi, which would be, times 3.14. That's easy enough. Excuse me, 31.4. Inches is what I'm looking for. They might have us round. I can't remember. Nope, 31.4. D. Hey guys, that is a good thing for us to go back over. I know it's been a while since we talked about circles. Circles are everywhere. Finding the distance around them, just space inside, that's an important thing for us to know how to do moving forward into eighth grade and beyond. So it's good that we've gone over these things, and hopefully you remembered some of it already and you didn't need a lot of help from this video. If you did need help from the video, I'm glad that I was able to give you a little bit of help. I will be continuing to post these just to help those that might need it every day. And it looks to me right now, if this continues and we get past these review lessons of quizzes, problems, we might start looking into some new lessons after this. We'll just see how all this madness with the coronavirus goes. But if we start doing new lessons, then we will do something similar to this style where I'll post some videos, show you how to do the problems, give you some practice, and then post another video for help if you need it. So that'll be how we roll for the next while, and we'll just make the best of what we've got. And I miss seeing you guys. There's a lot days go by a lot faster when we're together, but you know what? It is what it is, and we are where we are. And I hope that you guys are staying well and that you're getting to spend a lot of time with family, and um, things are good at home. So just let me know if you have any questions. Send me email, messages on Schoology. I'm available 8 to 3 every day. I have my phone on me if I have to go run an errand or if I'm eating or whatever. But just let me know. I'll get back to you as soon as I can. Y'all have a great day.